Here is another example of shear force diagram and bending moment diagram. So here is our beam. These are external reactions which have been already computed. This 10 kilonewton is a rectangular load which is acting per meter. This distance is 0.75 meter and this distance is 1 meter. So moving towards the shear force diagram, first you can see that this triangular load is acting downwards. For the distance of 0.75 meter, we will multiply 10 into 0.75. So the shear force diagram will move from 0 to direct minus 7.5 up till this point. After that, you can see that 15.31 kilonewton load is acting upward. So we have to plus minus 7.5 plus 15.31. So the shear force diagram will move and reach up till this point 7.81. After that, this rectangular load is acting. This 10 kilonewton is acting at a distance of 1 meter. So we have to subtract 7.81 minus 10. So we will reach up till this point minus 2.19. After that, you can see that this reaction is 2.19 kilonewton. So we have to plus this 2.19 kilometer and it reaches at 0, which means that we have computed it right. Now we want to calculate the point at which this shear force diagram is 0. So you can simply calculate this point by, for example, we suppose that this distance is x, then this distance will be 1 minus x because this is 1. So we suppose that this is x and this will be 1 minus x. Now these two are similar triangles because the angle is same in both triangles. So we will suppose that perpendicular divided by base is equal to perpendicular divided by base. Tan theta basically in both triangles will be same. So perpendicular divided by this base is equal to this perpendicular divided by base of this triangle. These both are similar triangles, and by equalizing these two we can simply form an equation, and from this we can calculate the value of x, which is 0.781, which means this distance is 0.781. Now we are able to calculate the area of this triangle and this triangle. So moving towards the bending moment diagram, this negative shear will cause it bending moment diagram to move downward side first. So first we will calculate the area of this triangle. This area of this triangle is calculated as minus 2.81. 1 by 2 into 7.5 into 0.75, it is minus 2.81. So bending moment diagram will move first downward. After reaching at this point, you have to calculate the area of this triangle. If positive, it will cause a moment diagram to rise towards 0. So calculating the area of this triangle and adding it into minus 2.81, we will simply reach at this point 0.239. Here you can see that this is the negative shear and will cause again the bending moment diagram to fall downward, so it will reach at this point. You can simply calculate the area of this triangle and subtract it from 0.239, you will reach at 0. So which means we have computed it right and it is closing at 0, and this diagram is also closing at 0.